Let's discuss fourth example of divisibility test. The question was asked in CAT 2008. The question is, suppose the seed of any positive integer n is defined as follows. Seed n is equal to n if n is less than 10. It means seed 2 is equal to 2, seed 5 is equal to 5, and so on. And seed s of n otherwise. That means if n is more than or equal to 10, then seed n is equal to seed s of n, where Sn indicates the sum of digits of n. For example, seed 7 is equal to 7 because 7 is less than 10, hence seed n is equal to n, so seed 7 is equal to 7. While seed 248, now 248 is more than 10, that means seed 248 is equal to seed 2 plus 4 plus 8 is equal to seed 14. 2 plus 4 plus 8 is equal to 14, hence seed 14. Again seed 14 is more than 10, hence this is equal to seed 1 plus 4 is equal to seed 5. Now 5 is less than 10, hence this is equal to 5. So this is how seed function is defined here. Now question is, how many positive integers n such that n less than 500 will have seed n is equal to 9. Now just think of the first example of seed 9. Sn is equal to 9. Then seed 18 is equal to seed 1 plus 8 is equal to 9. Next example such that seed is 9 is 27. Seed 27 is equal to seed 2 plus 7 is equal to 9. So basically sum of the digits is equal to 9. We all know divisibility test of 9 is sum of digit is equal to 9, then number must be divisible by 9. So in other words, question asks us n less than 500, how many values of n or integer less than 500 divisible by 9. So answer is 500 by 9, quotient is 55. That means from 1 to 500 there are 55 integers divisible by 9. Hence answer of this question is E, 55. Okay, next question is that was asked in CAT 2007. The question is, consider 4-digit numbers for which the first 2 digits are equal and the last 2 digits are also equal. How many such numbers are perfect square? So question says a 4-digit number is in the form of AABB. First 2 digits are equal and last 2 digits are equal. So how many this number is a perfect square? So we will solve this question by 2 methods. First method, this is a 4-digit number, so we can write down this number as 1000A plus 100A plus 10B plus B, or we can write down this number as 1100A is equal to plus 11B. If you take 11 as a common, then we have 1100A plus B. This number is a perfect square. If n is this number, then n is a perfect square. Now have a look at this number 100A plus B. 100A plus B is a 3-digit number whose middle term is 0. Just put A equal to 7, B equal to 5. Number is 705. Just put A equal to 2, B equal to 6. Number is 206. Just put A equal to 9, B equal to 2. Number is 902. Basically a 3-digit number is in the form of 100x plus 10y plus z. Here y term is missing, that means middle term is 0. So 100a plus b is a 3-digit number whose middle term is 0. Now since this number is a perfect square, hence this 3-digit number must be in form of 11n square, such that 11 into 11n square, we have 11 square n square, and the number is a perfect square. So this 3-digit number must be in form of 11n square, otherwise it will not be a perfect square. Now how many 3-digit numbers are in form of 11n square? Just put n equal to 3, then we have 99, a 2-digit number, so rule out. N equal to 2 and 1, definitely will have a 2-digit number, so rule out. Then n equal to 4, 16 into 11, 176. equal to 5, n equal to 5 is 25 into 11, 275. N equal to 6 is equal to 36 into 11, 396. N equal to 7 is equal to 49 into 11, 539. N equal to 8 is equal to 64 into 11, 704. N is equal to 9, then we will get 9 square 81 into 11, 891. Out of these numbers, only one number exists in the form of 100a plus b, or only one number has middle term 0. That means 100a plus b must be in the form of 704, or a must be equal to 7 and b must be equal to 4. So only one number exists, that is 7744, and it is perfect square of 11 into 8, because n is equal to 8, 88. Hence only one such number exists, that is a perfect square and in the form of AABB. Now let's solve this question by another method. AABB is a perfect square. Last two digits is same, that means B must be either 00 or 44. No other possibility exists. The theory for the same we have already seen in the properties of squares and cubes. So let us suppose B equal to 0. In that case numbers are 1100 or 2200. Just assume 1100. This is equal to 11 into 100. 100 is a perfect square, but 11 is not a perfect square. That means this number is not a perfect square. Similarly, neither 22 nor 33 nor 44 till 99, none of the number is a perfect square. Hence, if b equal to 0 or last two digit is 00, the number cannot be a perfect square. So b must be equal to 4. Now, as we have seen earlier, this is a 4-digit number, so we can write down it in the form of 1000a plus 100a plus 10b plus b, or 11 into 100a plus b. And we have also seen that this number must be divisible by 11. This is a 3-digit number whose middle term is 0, hence number must be in the form of a0, b, middle term is 0. But we all know that b equal to 4, hence a0, 4. Now we know this is a 3-digit number whose last term is 4, middle term is 0, and number is a multiple of 11. Now apply the divisibility rule of 11. If number is a multiple of 11, that means sum of the alternate digits, difference between them must be equal to 0 or multiple of 11. Now in this case, the required difference is a plus 4 minus 0 must be equal to 11, or a plus 4 is equal to 11, or a equal to 7. So we have seen only one value of b, that is equal to 4, and only one value of a, that is equal to 7 will satisfy this condition. That means only one number 7744 exists that will satisfy this condition, or only one 4-digit number 7744, that is a perfect square in this format.